Audio test. Okay, audio seems to be okay. So, welcome to the Scourge of Hesitancy. Today we are working on finishing up the UV embedding. We're embedding UV data with our images into our executable and making it much more convenient to do fun UV related things. So, let's get our beverage of choice ready for the day. You do you do your energy drinks, your Mountain Dew, your scotch or tea, coffee, whatever. Some people even drink water once in a while. Actually, I'm drinking about a gallon of water every day now. Feels good. For those of you not from the US, that's around 4 liters. Good to be hydrated. And we will get started. So, yesterday we had some loose ends that we didn't get around to, and that's fine. Loose ends from yesterday. Okay, I think that is a good chunk for today. Let's check our to-do. So discarded or delayed tasks. I did want to add a couple things that I thought of. We do want to animate over a color gradient instead of just between two colors. We do want layers eventually, although, yeah, I guess we can call them layers, that's fine. Scene manager, right now we're just looking them up by index, not being able to look up a name for a scene or vice versa, an index from a name or a name from an index. So that would be nice in the future. Right now, all of my scenes are hard-coded, so maybe we want to add some flexibility there. When it comes to virtual functions, I try to avoid them as much as possible, but the scene only gets those functions called once per frame, so it's not a huge overhead. I don't think that using virtual functions and inheritance from some abstract scene would cause me any major performance issues. So that's not too bad. We've got different audio things we could do in the future. So what do we got now? I don't want to do it now, but eventually I think I want to abstract quad and color and batch quads. Right now we have a lot of duplicate code between our batch quad and our quad management. So for the batch quads, we've basically written it 3 times between text, our batch texture quad, and our batch color quads. When really the quad management itself could be its own component that we include in those other classes. That's one thing we want to do in the future. Another thing we want to do is end into a separate component for reuse. The other thing we want is the vertex buffers, and I knew this going in, that This is not the best way to deal with them. Vertex buffers from array of floats to array of vertex objects or structs, maybe structs or class objects. I don't know which way I want to go with that yet. There's a lot to be said for just having all of the members of a vertex buffer be public and not weird. Here might be an appropriate time to use templates. Okay. Let me think. What else? Yeah, those are two things we want to do in our next game. The fact that we're dealing with these two things right now and we're not happy with them it's not bad enough that I need to go back and refactor now and update those. So we'll just suffer through with those. Anything up here? If there's spare time, I really want to knock this one off my list. It's basically the last animation I haven't been able to get around to for letter color changes. Shouldn't be that hard now. But this is a good place to start. Did I say new button? Yes. We're going to use texture quads here eventually. So this will be ready to go soon. Okay, so let's get started. UV values. Let's go to our thingamajig. We just run it. No, this is not what we want. We were running tools in embed PNGs. And then we were looking at image warehouse, CPP, which is a very large file. Actually, well, we can change that later. Nobody's actually referencing it. So we go down to where the UVs are defined. And what we have are some of these are outside of the bounds of 0 and 1, which means either I'm doing some math wrong, or alternatively, because of the way that UVs are being specified pixel-wise, dividing by the width and the height, we could end up with something bigger than 1 if I've underestimated the size of the image, which I think is the case with these three. The playmat I know is a stretched out image because when we first made it, we didn't have the window sizing the render area properly. The books, I could well believe those are off because I just guessed at the size. I didn't even look at the image size. This should be fine. And this should be fine. Okay. So really it's probably me using invalid widths and heights for an image, which we can change. We can go into images. There we go. Think what I'm doing here. And here we assumed that the playmat was 1024 by 768, but when we took our screen measurements way back in the day, we weren't taking into account the window frame. So when we drew the image for the background, it was not 1024 by 768, it was slightly different. So I need to go look up the size of that image, which take me just a minute. Assets, images. I hate Windows, thank you. So the playmat, this is a useless program. Why would you open an image for me and not tell me the size of it? You know what we can do? We can look this up in Image Warehouse. Okay, there it is. 729 and 40. So let me just scribble these down for reference. So the playmat is currently 1008 by 729. The books are 230 by. So now if I go to images.txt, here, let's see, 512, half of 1008, it's just 2 equals 504. So we're just going to change 512 to 504. That should give me the 50% I would expect. Instead of 768, well, instead of 1024, we're going to take that as 1008. Okay, and then 768 will change to 729. And lastly, once we're verifying that the math is correct and that I was just assuming incorrect image sizes. Last thing is 729 divided by 2 is 350, 360, 364. So 384 to 364, 5. Somewhere around there. Okay. So I should fix that one. Books are 40, I remember that. The width is 230, so that can be 115. And the halfway mark is at 115. So we would expect books to now be nicely in the 0.5 and 1 ranges. Shell, run it. Image warehouse. Yes, I know it's a big file. Although, honestly, modern standards, it is not that big of a file. The fact that Emacs bogs down in such file sizes is a little bit disappointing. Okay. Now, books are 0.51. Yeah, those are all nice numbers. These are almost all nice numbers. That's really close. I'm fine with that because it's off by, we had an odd height. And that is one of the V coordinates. You know what we could do? We could put a line above here with the UV labels as a comment. It's not the worst idea I've ever had. Let's go to embed PNGs. So right here, I'm just gonna put in the incorrect. I'm gonna put in one of these. This will be U0, comma. Oops. V0, U1, V1, U2, V2, U3, B3, new line, wrap it up, and there we go. So now, in theory, our file is even going to get a 10 from UV. I know. Maybe today is our last day on UV, so maybe we can get some infrared going. Okay, so the build's done. Shell. Image warehouse. CPP. Reload it. And go down to our UV buffer. Oops, forgot to insert commas. That's okay, that's minor. It's in a comment anyways. There we go. Okay. That looks okay. Okay, so we've ticked that box off of our list. So we know the UV values are looking correct. We need the enumeration that we're generating to reference the tiles and sprites correctly. Because you're generating those UVs in a pattern fashion. I guess we could save it. That works well. Verified UV math. UV tests and verified UV math. Okay. Now we need the enumeration to output correctly, so enum class here, this one. Now, what we're doing is we're walking through each UV we have. And just outputting the key. But this gets more complicated if our UV type is UVs or what was the other one? UVs or rectangle. So if it's those two, we do things like that. We put this in a switch statement. Maybe we put this in a switch statement. Switch. Case. Case. And we use a call through. Break out of the switch. Case UV type. Whoa. UV type will be UV tiles will do one thing. UV sprites will do something else. And I know these are already going to require some local variables, so we'll just scope that. There we go. All right, looking good. Bring the heat. No, it's summer here, so I need cooler weather. I like it cooler. Want to get warm, I drink hot chocolate or eat some good hot sauce. When it comes to cooling down, like you can only remove so many layers before they start getting you for indecent exposure. Okay, down here. We have width, we have height, we have a row, we have a column. We walk through the X's, we walk through the Y's. But a lot of this is much, much simpler. We can just steal this to start with. So they're not outputting that much. We got the width, the height, the row, the column, that's fine, fine. But we're outputting. It's going to be something more similar to what we had before. Except underscore row modulus 0 3D underscore column modulus 0 3D equals a number, a bunch of stuff about columns and whatnot. So first thing is the key. We want that one first. Then we want the row and the column. Then basically this junk, I think, hopefully it'll just come straight over. Then we increment our UV count, increment our column, I'll reset at the top. That should be tiles done, in theory. If UV index is, oh no. So in this case, it's not about UV index. It's about oh, no. Yes, UV index. That's correct. Oh no. If UV index equals 0, and row equals 0, and column equals 0. Basically, the first tile of the first UV can get this comment in there. Okay, good. Now, basically the same thing for sprites. Here. So we get our width, we get our height, sprite count. We steal all of this, throw it in. Starts with modulus s underscore modulus 0 3D equals this mess here. Well, that goes away, and we basically get this and the sprite count. Then we get the actual number, we get a comma or not. We get the get these two lines. Except instead of row, we get sprite count. Sprite count. Okay, let me think about this. I think that's it. All right, let's try it out. Data was not declared. Yep. Same thing when we're working with sprites, we have to know what our strides are. Height not declared. Okay, we have to look up the width and the height. Interesting. Gotta figure out all this lovely copy paste, so we are so close. Oh, widths and heights. I thought we made those. We did. Okay. So let's go into UV tiles where we were doing it before. Where did we get the width and the height? Right here. Every image we can get the width and the height easy enough. Now it's just formatting. CD tools, bin, embed, bin cheese, exe, image warehouse, reload it. Well, close. Could simplify a couple of things. Make it a little easier to read, I think. So I went to an awful lot of effort to have these two lines, but we can do it much simpler. For every image, we'll just output 1, 2, 3, 4, 1, 2, 3, 4. We'll just do it here. We'll do it in line instead of trying to be so clever. Always make things harder than I need to. Yay, simplify. Always nice. One more. Only I could remember to put commas in places where they belong. Okay, last thing. These are not indented properly. I lost a semicolon somewhere. Perfect. Run it. Image warehouse. Okay, that looks better. Now, this one supposedly has tiles. But they aren't outputted here.
No.
UV tiles.
Boys, you stay home, please.
Width and height. Hmm. Okay. First of all, yeah, there we go. UV tiles. Let's log what we read out of our big file. Okay, what is happening here? Okay, there we go. Okay. This is definitely a UV tiles. There's our prefix. There's our size in pixels of each tile. So, it's all working. Write the header. For each image, if the image has any UVs specified, get the image width and height. I'll put the name of the image. For each UV index in that image, you figure out what type it is. These two are the same. Oh. Well. Walk across the width and the height. Increasing UV count, column, row. I don't know, man. I think they should be working. Yet I don't see any tiles in here. I want to see some tiles right below this guy. So we gotta figure out why. What's wrong with tiles? Sprites are fine. So close. I'd really like to get some testing going here before too long. Alright, tiles. We have our width and our height. Row and column. Generating UV tiles. Width, height, width. Generating UV tiles, tile size 10, 50, and image size 0. Oh, that's not good. Why is our image size 0 here? How can it be 0? The image warehouse has it at 256 by 256, and this data is output from the same array we're looking up the width and height from here. So when did they get set to 0? But it definitely is not 0. Widths. Widths. Gets allocated. Widths gets the height from parsing out the image. I got like an, that's just an access, that's just an access. Like I'm not setting the width. Delete widths and heights. I'll bet that's the problem right there. We only do that at the end of our main function. Something else overrode it. We freed that memory, and for some reason it didn't segfault, which blows my mind, but okay. That did not fix the issue. Always sad. Let's do a full clean. Make sure we're getting everything done. Huh. Widths equals 1 width per image definition. For every image definition, reload and set that width and height. I know this is correct because we output the entry sizes. We get those widths and those heights. So up to this point, we know that the width is right. Here we output the UV data, and the widths are correct there. More UV data, there's the widths. Entry count. Where we output the actual UVs, and those are correct. So if we go to image warehouse.cpp, we can see that this file does have those tiles defined. So the image has a width and a height here. Each row has 2 columns or 5 rows. That's all correct. So why, when it's here, does it not have a width and a height? So close. All right. Read everything in off the file. We've logged everything, it's correct. We write the source, which we have to do first, the implementation file. We have to do that because it has to find the width and the height. Height bin. First temp. temp width. This is our function that we passed in. Here, this is our function we passed in. We're passing it a width to store values in, called temp width. Load PNG decode 32-bit file has that and sets it. Compute a size, we write the binary file out as text. We could simplify this somewhat. That isn't the problem. Generating UV tiles in image size 0. Here. But it works for sprites. So that other file is not coming up with a 0 size. Just this one. Not redeclaring widths anywhere. They're only declared in one place. One. There we delete them. Here we're referencing them. String. We allocate widths. Widths plus image index. Heights plus image index. A bit of simplification, but it shouldn't make any difference to what we're doing. It's more like idle action while I think about the problem. Well, that does not work. Why not? Because of that null pointer?
Are you guys getting together after this?
Okay, I don't know why it's getting zeros.
Okay.
That is very disturbing. None of this matters. This is refactor without any real meaningful change. I like it better the other way, but that's fine. Widths and heights is definitely populated elsewhere. It's something stupid, isn't it? Image index. I know it has a UV. I know its UV is this, because we do get these print statements. But why on earth are width and height 0 for the image? All right, let's do this. Just log more stuff. It's sub image, oops, image index and heights times image index. Uh, 256 by 256. So why is it 0 there? I feel like my compiler is screwing me over again. Tell me I'm wrong. Okay, so at this point, right above here, widths at image index and heights of image index gives me a real value. Oh, these are float. And okay, problem solved. Sheesh. Now it's gonna magically work. What is it doing? Why does it think that I've saved this? So why does it keep telling me I need to save it? Come on. Sure. See, that's not even valid. Why does it want me to save it? I really don't want to restart my Emacs here. Might have to, though. Okay. Now it has a size. Yep, it's freaking float. Which raises the question, Yes, I know permission denied. Stop it. If this width and this height were invalid for tile, why were they valid for sprites? They're the same. It's the same code. Okay. 2 columns per row, 5 rows, all good. Okay, that's unbelievable. Okay, last piece before we can run an actual build on the generated code is here. These two need to be updated in the same way. Now that we know what we're doing, should not take long. So we're looking for what was in my output? Those 2 lines can go away. However, most of this is actually perfectly usable where we generate the other thing. Yeah. So we're going to steal all this. UV names. Boom. Okay, much closer. I don't think we need UV names to be quite as readable. It's not used for anything interesting other than writing output, so it's literally just an index lookup. So it's more like this. We put out the name, and then put a comma if we have to, and done. I think that's it. 1, 2, 3, 4. We print out the name. But yeah, that should do it. Okay. Someplace. UV count is not. Okay. Redeclaration. Easy to fix. Okay, now we run it. And it fails. Why did it fail? Possibly doing something wrong, but .419 widths. width has not been computed yet. Okay, so UV names has to be done after we load all the image data. Okay, quit. That's gonna drive me bonkers. Oh no, quit. I don't want that. Okay, there we go. Image warehouse. Load this thing. We have all these UV keys that we'll use later to look them up. And this one is wrong. That needs to be no comma there. Get data, get width, get height, get key, get index, apply UVs. UV names. We have this last here. Start count UVs. Yeah, we can put UV names. Well, where do we put UV names? Put them out. There's the UV data. There. All right. That was in the enumeration. If we look in the image warehouse, and the last one there also has a comma issue. In fact, sprites is not outputting. Oh, it is outputting it now. Yeah, 10. Yeah. Okay. So super close. Embed PNGs. Let's get rid of that extra comma. We should be ready to test. At least as far as does it compile. Woo. UV count less than UV total. UV count less than UV total. UV total minus 2, so UV count has to be 1. 1. Because of the default. That default's going to be the death of me. All right. image warehouse.hpp. Generated all this code. Commas look good. No! There's still a comma on this last item. That makes me sad. Which means image warehouse is going to have the same issue. Oh, it doesn't. Okay, so just the enumeration now. I can sort of change UV count to 1. Right, I'm just trying to save this file because there's no file there. Do not save the current buffer. Delete or end. Q to skip the current and all buffers. Control R to view this buffer. So literally, it thinks that I need to save my shell. Fine, quit. I don't want a shell. Yes, kill it. Get a new shell. Piece of crap. All right. Okay, let's see. What? Still no. Unbelievable. Can I not just run it? Can I run a build? File. Run it. Image warehouse dot. Okay, there it is. Now there's no comma there. Good. Phew. Then image warehouse dot cpp. Yes. Good. Okay, so all that's correct. So in theory, we can build this project finally. It's been a day since we've been able to do that. Generating code, sometimes you end up in weird states. So as long as the image warehouse compiles, all that's left is the apply function. How are things going in the chat? Pretty quiet today, except for low efforts. Oh, unused parameters. I'm fine with that. Yeah, apply UVs. That's fine. We haven't implemented it yet. It's fine. Fine. This though is sad because it's not entry count. It's UV count. Oh no, it is entry count. Okay. So you've that up. And this one, yeah, start and count. We've messed up both of them. Okay, super close. M underscore entry UV start and count. Okay. Okay. This thing comes out. This thing comes out. I think that's it. So really, I'll put one line per file after we walk through all the UVs. And if that doesn't work, okay, so the UV names, the start indices, that looks better. That's 5. And no duplicates. One did have, let's see here, let's look at images.text. So, first one has no UVs actually. So it should start at 1, that's fine. This one should be 1. And this one should be 7, then 10, then 20. Okay. Start index happens after we write that. There we go. So that's 1. The next thing we do is similar. Image count. All we care about is the count, so this just works. We also have an extra new line at the end. Okay, the dough starts at 1 and has a count of 0 textures or UV mappings. Playmat starts at 1. It has 3, so books has to start at 4, which has 2. So the first GBZ starts at 6 and it has 10, 16, and 10 more for 26. Alright, finally. Okay. Now this should compile. With lots of warnings around apply UVs. It should compile. Then we just implement that one function. Oh, code that generates code. It can get a little bit twisty, especially like on Fridays we do compiler days. Once we start writing the tokenizer generator, you'll see that it gets very mind-bendy. So you have to think about the code you're writing, which writes out text, which another compiler will read and parse. So it's very meta. Okay, and then yeah, that compiled, so that's good. Lastly, to do implement. Here we are. So here's the deal. We pass in and say, here's the image index that we want to apply UV to. Oh. No, the UV key. Okay. So this is the index of the image we're talking about. And I'm going to pass you 8 parameters to stuff the results into. And I'll tell you which UV I want. By default, it's the one that just includes the whole image. Does that all sound correct still? Okay, so firstly, we assert something like this. You can't tell me to look up an image that we don't have. Next, we want an integer representation, UV key, or UV index, equals static cast integer of the UV that you passed in. If UV index equals 0, or something more complicated, we could assert that, but I don't feel like it. Or what's that thing called? Image warehouse. We want the entry UV start index. Of index is less than or equal to UV index and UV index is less than Start index and index plus this one. Ooh, okay. Is that complicated enough yet? So if our UV index is 0, that's always allowed for any image to just show the whole image, standard stuff. Or it has to be between our start index for that image, and it has to be less than start index plus number of UVs allowed for that image. We could assert that. Or we could put a nice, clean error message that actually explains what's going on. But now we're writing code which writes code which outputs strings, so we have to escape everything. Fun times. Okay. Error image warehouse dot apply UVs. And we can output a lot of interesting things there. But this stuff is all correct. Then we can do this. The contents of view. Let's see here. We can get float pointer UV data equals image for UVs at UV index. And now U0 equals UV data sub 0. V1. 1, 2, 3, 4, 5, 6. I don't know. What am I doing? 1, 1, 2, 2, 3, 3. 0, 1, 2, 3, 4, 5, 6, 7. That's what I wanted. And that's basically it. Except for the error message, which is not going to be. We could output all sorts of things. We can output the image index, the image name. We could output the valid range. We could output the name of the key that you passed in. Okay. Now remember, we are writing strings, which are writing strings. You have to double escape a number of things. For image thing, UV is invalid. These are double escaped. must be. Is that enough? Is that enough for me to? Must be between. Let's just do this. Let's just do it this way. All right, now commas. Where's image names? Do I have image names? M_ entries are just the data. Key to index, but I have an index to key map. That's what I want. Index to key map of index. Have the index itself. We're going to pass in also the UV name. I'll do this S. UV names, sub, UV index, and the UV index itself. Using like 2 more class labels here. That may be enough. So let's see here. Image warehouse, apply UVs. For the image named index to key map at the index and the index. The UV called whatever at this index is invalid. I think that's it. All right, let's see how it looks. Yeah. Build target equals embed PNGs. Here's a warning. I don't like warnings. Okay. Right. Image warehouse. Reload. There should be no more to do in here. Apply UVs. Let's take a look at it. Assert. Our image index has to be valid. Then we get the UV index that we're passing in. If the index is 0, or it's between the start index and the start plus the count, then we can get the data for the UV, which is an 8-element array, and apply it. Otherwise, log error, image warehouse.apply UVs for the image, blah, 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 UV. Oh, darn it. I missed something. Oh, I need to double escape this string. Maybe we don't do that. Maybe we just do it like that. We can both run it later if we want to. Image thing and thing is invalid. Index to key map, index, UV names, UV index, UV. Okay. Whew. Now, this all builds. HK, clean, and debug. And all that's left is to test our code. Finally. We will commit before we do that, though. Always have a safe point to go back to. Okay, wrapped it all up. As far as major code changes, in an hour and a half with some talking. Not too bad. Oh, shoot. Log has not been declared. Image warehouse is not importing a log. Wow. Right header. Good heavens. Build target. PNGs. There's always something. There just doesn't seem to be a way to avoid it when you're generating code. No. Okay, now source build debug. Does it run? Does it play? Seems to play. Things happen. Settings. Okay. We haven't broken anything yet. Phew. All right. Not bad, not bad. Now we do have a test. So let's go to our journal. Enum and UV names are done. We have built this. We need to do the testing. Updates to embed PNGs to support UVs is done. Generated code builds and nothing crashes. Testing to follow. Embed PNGs now has UVs. Testing pending. Boom. Not bad, not bad. Okay, now we get to the cool parts. First, I think it's time for restroom break. And we're back. I mean, most of this stuff was done yesterday. Just actually, I also added sprites. I'm gonna tile and a width. Okay. There we go. Honestly, mostly this was done yesterday, except for these loose ends. So I don't feel bad about marking them as done. The code is mostly done. Lots of testing. All right, testing. Here we go. Sandbox. Really, it's only TexQuad and TexQuadBatch that can be used for this testing. I don't really care about the color quads at all. So let's go to texture quad. That's always the simplest place to start. Set texture. When we set the texture, we need a function. Need a function. What does that function need to do? It needs to okay. Then we need just a teeny bit more tooling here. I want to be able to request the lowest and the highest available UV elements. So we need to get that information out of the image warehouse. But that is not that bad. Blah, blah, blah. There's the integration. Hit with apply UVs. Let's just get a little bit more functions here. It's not a charge star, it's going to be an emitter. UV key. There, I think that's it. Apply UVs. We don't need constant there. Okay. Oh, actually, this does not need that. argument there either. This one does. Do I want first and last, or do I want first and count? First, last, count. Let's see. Maybe just do it first and last. You can always do the subtraction yourself. You can do whatever you want with it at that point. Okay. So semicolon, we're going to put braces around it.
I am really tired of you and all me.
Okay. Also need this static declaration here or here. Okay. Is that everything we need?
Mom.
Do I want to do the... there might be one more thing I want to add to, but that's okay. We'll get there. Okay. So that's that one. Maybe we get count. Um... No, let's get UP. Okay, so there's that. This one needs to be statically cast. as a thing. This. Just returns an integer. Last piece. We want static const char star UV name int UV index. UV, no, not UV key. Okay, and then UV names. Static cast integer of key. That is basically it. So here, we can just do UV name like that. Build target equals embed ng's. Because we will want to enable people to make inquiries about their own stuff without resorting to looking at the gigantic file. There we go. Oh, CD tools, bin, embed PNGs. Static cast image warehouse UV key of the start index of the image at that index. Okay, these two should both assert this. This one does not need an assertion because this is a strongly typed enumeration class. Good. That's fine. Okay. Almost there. We just copy this line and this line. No assertions needed for UV name. Build, run. Let's take a look, make sure that those functions are being declared. Get first UV, get UV count, UV name. Okay, maybe we call that get UV name for consistency. Boom, run it. Ugh. So close. Oh, I know why. So I didn't rename it everywhere. Get UV name. Now, oop. No match and function call. Oh, yep. You are correct. Once again, let's see here. Static cast to UV key. That's it. A equals embed PNGs. And now it works. Okay, back to testing. We can now do testing things. Phew. So, added some informational methods to imageware. It'll be useful for testing. We now go to TexQuad. To do optional UV. We can finally do this. Void set UV according to image warehouse. Don't have access. Well, we would probably have access to it, but we're not declaring our dependency on it explicitly. UV key. TexQuad CPP. After we set texture. All right. Ooh, finally. Finally, you're getting there. So we can set the UV of this particular texture. By doing something clever. So here's init UVs. That just gives us our default. We don't need this one. Actually, let's do this. Image warehouse, apply UVs to mtext dot, so your texture. I would like to get the index. Yep. I would like to apply our changes to these things. Except plus that. Lastly, we apply our key there, and that's it. Not quite. Assert. We can assert that the texture is not null, or could assert that the texture is not null. What do we think about that? Hey, Fit Rider, how's it going? Sipping your tea? Is that what's going on? Welcome, welcome. So I can either assert. Where's it? There we go. Our texture is not null. Is that enough? Okay. When we set texture, we will set UV using the default. And mark. Hmm. I guess we can mark it dirty no matter what for now. Maybe we can get cleverer. We mark it as dirty so the renderer knows it has to update the vertex buffer before it draws it. Now, it may be that every time we load a new image, there are no differences. Maybe nothing changes here. In which case, we don't want to upload the new thing. So do we keep track of the UV that's loaded up? We could do that. No, sir, I take amphetamines. Okay. I don't know, the emotes you got there look like they're somebody sipping tea, so you just load your amphetamines into some hot water and call it good. Maybe we just mark this as to do. Consider storing last UV key. Checking for dirty. That's fine. That's a to-do. We don't have to address that today. So that's one thing. The other thing is TexQuadBatch needs something similar. Get TexQuad. Set UV. Oh, the other thing we need to do. Remind ourselves in our implementation that we have a default. TexQuadBatch. Right after we set texture. We need the input index. 2, 3. Here. TexQuadBatch. Oops. Okay, so first thing we do is we assert the quad index is fine. Oops. So this is all stuff from TexQuad. I'm just going to apply this. Set UV. Good heavens. Hold on a second. Are we not checking set texture? Okay, so we're not even checking to see if it's being updated or not. And that's fine. Hmm. Hmm. We'll consider this. To consider checking texture is the same. To reduce UV updates. Do we just do it? All right. Texture P equals this. If underscore texture is not equal to P, let me get P and we set a default UV. X equals P. All right. Kind of don't want to store UV key right now. We will consider it though. Okay, so that's a little bit better. TexQuadBatch. Current quad offset. So here, we would have updated it. And here we can do set UV to a default. So this doesn't need it and this doesn't need it. Only if it's actually set does it get set. Okay. Right. So here, we insert things, we do that. I would like to see where this is actually used. In here, basically this, set UV. If the texture is invalid, it's fine because we don't look at the texture anyways. We don't have to insert anything there. UV is 2 and 3. Oh, good job. Okay. Int quad offset equals the quad index times stuff. Vertex offset is 5. Oh, no. Vertex times 0. No texture slots. Vert offset with that mess. Zero, 1, 2. I must have deleted the third one. 3 through UV.
You found Hannah still wearing it on your leg. Oh, yes, you're all right. In there.
There we go. We get our quad offset. There's all of our UVs. So basically, this thing. We have to get the texture index. Which do I remember how that works? M_ textures.
You chose correctly. You can go with one. No rules, then.
Okay, so the other thing we need to check. Almost there. This part's the only remaining piece. When we set the texture slot. I need the texture slot number. There we are. Sure. Okay. We need to look and see what our current texture slot is.
How is that get put away?
Let's have all integer if texture slot, we could have its texture slot is greater than or equal to 0, and underscore textures at the texture slot is not equal to null. Then we can do these things. Otherwise, whew, okay, we're close. I had to take a drill to my laptop 2 weeks ago. Uh-oh. Like a power drill, I assume? Like, was it to fix it or to destroy it? If you're gonna destroy it, man, there's a lot better ways to do that. We've got firearms, explosives, all sorts of fun things. Acid. TexQuadBatch. Do I really care what the texture slot is, though? I mean, I do because I have to have the index, so that's fine. Okay. That doesn't quite work. Okay. There we go.
Then show me the thing.
All right, let's see how many things we broke.
Whoa!
That is close. One small letter transposition. Oh, okay. What? Okay, I know what's going on here. Oh, what? Quad UV. Matching function. I don't believe that.
It's not funny. I'm not playing games.
Oh. Aha. I know exactly why. We do have to pass in quad index. Quad offset. Drill it through and finally got to change the thermal paste and clean up the fans. Oh. damaged a Phillips screwdriver in a deep groove, so I couldn't get a grip and I couldn't pinch it out. Oh yeah, yep. Drilling out screws, always fun. And yeah, I've got 2 fans I need to replace on my machine. I don't like it. I don't like tearing into expensive electronics. I'll do it. It's not a problem. Just I'd rather things just worked longer. When I was growing up, we had the same PC for, gosh, I don't know. It was like maybe a decade. Okay. All right. So in theory, the default UVs are being set and it looks fine. Now it's time for actual testing.
I know, I saw that.
Set quad 0. So who's doing set quad? Probably in here. Interesting. Extra slot 0, 1. Is that in my sandbox? This one. We need that as much anymore. Okay. So it's working. Now we need to test. We need to do things to this that make sense and some that do not make sense. Right now, the default behavior should change nothing about the way that our program works at all. Yeah, I used to work in a machine shop, and the worst feeling in the whole world was snapping off either a reamer or a tap inside of a hole. Then you got to drill that out, because then you're drilling out tool hardened steel, sometimes in aluminum, sometimes in a mild steel, but gosh, that was, yeah, bit extraction, so hard. So anytime it's some little teeny computer screw, it's like, oh, I guess it's not that bad. But you're not crying, so I'm guessing that it all worked out okay. Okay. So we want to test. What we want to test is lots of things. So how do I want to test this? Basically want to hit a few keyboard strokes here and there to select different quads, different UVs, list them out. So I think we're going to do this. We're going to go down to do update or on update. There we go. Zero, 1, 2. Input is key press. input key space, I guess. Then we're just going to reset all the texture quads and everything should be fine. We have images text. We have 1, 2, 3, 4, 5 images to test. We have 4 texture quads and a text quad. So let's do this. Sandboxing. As part of this testing, we're going to have an int underscore selected quad, selected text quad, will be 0. Equals 0. Then we need a texture index. Int underscore selected UV index. Okay. So I want to be able to set a number of things, restore things to default. All right, so we need some functions here. Apply texture and UVs. We should log the texture and UVs so we can see what we're doing. So let's implement those. Log texture and UVs. Odd text UVs. Sandbox. Sandbox. You want to know what texture, what UVs. Best viewers on somewhere. Yeah, I was afraid I was going to end up damaging. Yep. Especially you're drilling into like one of those soft plastic cases, probably. Really easy to make a mistake there. Drill through something you didn't intend to. So I'm glad you got it all put back together. And now we have our first bot for the day. Say hello to the bot, fellas. quad texture UV test. Number 1. Which quad? Selected TexQuad. Equals 0. Then we put something out, otherwise we put something else out. Let's just break this up. Let's make it less inline. Quad batch. Oops. TexQuad. TexQuadBatch. Modulus D at this thing minus 1. Okay, that's the first thing. The next thing we need is which texture is selected. So we go from 0 to 5. Texture. S modulus D. M underscore selected. Texture index. And image warehouse. We want get E. There we go. Okay. And lastly, the UV image warehouse. Get UV name underscore selected. UV index underscore selected UV index. This one has to be static cast to image warehouse UV key. Boom. All right, if we want to apply this stuff, and apply. Oh. TexQuad. Set texture. TexQuad.set UV. Something similar here. What do we even call that? Sandboxing TexQuads. Set quad UV, set quad texture. Selected UV index. We then have the static cast. To image warehouse UV. Okay. So I start off by logging everything we're going to do. Then we can apply it. Reset texture UV text. Puts everything right back the way it was in theory. Okay, so that's one. Two. If you pick up or down arrow, okay. We're gonna pick left and right arrow. And then like plus and minus, I guess, right? Plus, minus. Input.hpp. Minus, there is no plus, is there? KP add, KP subtract. I can go with that. Okay, so if we go up and down, we're going to move up and down the selected texture quad with wrapping. If image store. Oh, we can do this. Modulus 5. So it should go 0 to 4. That's not modulus, that's multiply. Oh, let's do it the other way. If m underscore selected text font is greater than or equal to 5, 0. Minus, if it is less than 0, set it equal to 4. Okay, left and right, we have 5 embedded images. So I think we can do a similar thing here, except instead of TexQuad, we do texture index. All right, now the tricky one is this KP add and subtract. It would be nice if when we set the selected texture index, it gave us a rundown of all the UVs that are supported by that index for testing. Plus m underscore selected UV index. And we'll do strange and mysterious things to it. Oh, maybe we do just simplify this output here. Pressed up or down, something changed. Instead of logging the whole test over here, we only see the changes. If we press left or right, then we can log the texture. And if we did KP add or subtract, we log this one. The only piece remaining is when I set the image, I would like to list out all of the available UV keys. Yes, I think so. do period here. Just the log. Log everything. Okay. All right. This one needs to tell me all about UV stuff. Ooh, put that into this period. Selected texture index. So we get image warehouse UV key start key equals image warehouse gets UV's what was that called? Get first UV for image given this. Page count equals get UV count for image. When we set the texture index, selected UV index will be set to 0. Just easier that way. Now it's always consistent. We get the start key, we get the count. Um, UVs. Oh. Let's log all the UVs we can have. 1, 2, dash. Modulus S. Modulus D. Image warehouse. Get UV name from image warehouse. UV default. Default is always an option. And static cast to integer. Good. There's one. 4 int index equals 0, index less than count plus index. Get a int start key, start index equals static cast to integer of our start key. Okay. rename of the static cast to image warehouse UV key of start index plus the index within that. Then basically this thing. If start index, oh darn. All right. If underscore selected texture index equals 0, then we get plus, otherwise we get minus. If unselected texture index equals start index plus index, okay, let's just see how this does. Okay. Selected texture index. Selected UV index. Static cast to image warehouse UV key. Just like quad text. Get UV name. Oops. Not parentheses and brackets. There we go. And same thing here. What's my apply? I guess that's enter. Up, down, left, right, add, subtract. This is the complicated part. You want these three lines in here. because the loop around is a little different. If we're at 0, we want to go to the start index. Start index. And then, because it means we can print from default to the first real UV coordinate, UV texture. Then select UV index is greater than or equal to, oh, no, otherwise, we just increment. Select UV index. Yeah, underscore select UV index is greater than or equal to start index plus count. Then we loop around to 0. And done. Here under subtract. If we are, oh, no. If our selected index is equal to 0 plus count minus 1. We loop around to the end. Otherwise, minus minus it's less than start index. And we pop down to 0, and then 0 to the end. Okay. I think that's that. Okay. I doubt we did it all right on the first pass, but this means I can use about 8 keys to get every combination of thing that we want, in theory. Let's compile, see where that leaves us. Okay, then we go to our sandbox. We did not crash. We are told that we're dealing with the texture quad with the dough as my texture. It's using the default. What? Doesn't even make sense. Oh, do I? Yeah, bookcase should not be in there. So how did that get in there? Dot. Huh. That's not right. We hit up. TexQuadBatch 1, 2, 3, 4. Background, good. We hit left, right. That should be fine. Now let's go to books. Log it, and we have default, right, and the tile. That's not right. I feel like we are close, but there's some issues. This default one should have the plus sign. What's in my image warehouse there? Default doesn't have a comma after it. That's why it's appending those two strings. Thank you, C++, for being dumb. Comma. New line. Oh. Comma may be optional if we don't have any UVs. UV total greater than 1 question mark, comma, otherwise don't. Build target equals embed PNGs. Nope, that's a comma, not a colon. Bin dot slash embed PNGs. UV names. There, that looks better. Okay. Source. Oh, I guess we need to build it. Nope, nope. I did not want to do that. Debug. Hop into our sandbox. Cheap view, we got 2 bots. Woohoo! They're even advertising for the same thing. Look at that. How clever of them. Twice as much advertising. They're so smart. So smart. Okay, now if we hit period, the first texture doesn't have any UVs defined. So if we go, let's see, up and down arrow just changes which quad we're running. So left, right. Let's go play mat. That should have, oh, why do we have bookcase 1? That should equal, like, it tells me the selected UV is that one, so why is that not a plus? This one is. We are so close to being able to just use this, I think. If we hit spacebar, it should reset, whatever. Okay. So keypad minus, plus, minus, plus, plus, plus. Okay, so that's not working. Minus default stays at default, plus goes up to bookcase and then alternates between bookcase and default. I know that for this one there were 3 UVs plus the default. Okay, 1. Select the texture index equals 0. Select the texture index equals the start index plus the index. Every time we selected UV text. Texture automatically gets a UV redo. Okay, when I hit period, everything else looks good except for this thing. Selected index, start index plus the index. Okay. AP at we get start, we get count. If we hit plus and it's 0, it becomes the start. Otherwise, we increment. And if we are greater than or equal to the last valid index, pop around to 0. We're at 0, we go around to start index plus count plus 1.
You're so wrong.
Minus minus. If it's less than the start index, we pop around. There we go. That's one issue. Okay, sandbox. Dot. All I have there is default. So KP plus and minus. No, shouldn't do anything. Because this image shouldn't have any UVs. Okay, I know what's wrong there. Okay, next, texture. Which I think is backwards from the way that my mental model works. We can list all those textures. Default is not marked as with a plus. Plus, get 16, 17, good. 18, 19, 20, 22, 24, 25, and then it should pop around to 0. Minus, back around to 25, yes. Okay, so those work. It's just a 0 UV texture that we have to find now. Count equals 0. Do this. And that should fix it. Okay. Right, in the sandbox. We should, oh, I want to reverse one thing. Left and right. Left should be subtract, right should be add. That will work much better in my mental model. Okay, now we can test anything, any combination, and we have not applied a single one yet. So, we're going to stay with the TexQuad. We have a texture. We hit enter. That should apply it, which we can't tell the difference because that is the default. So, if we use the left arrow key, we go to playmat with the default. Go to playmat. And if we hit enter, it's a teeny tiny little version of our whole background. Nice. Now we can use keypad plus to get just the bookcase, and it's not going to be just the bookcase. We totally faked the UV. Actually, that's shockingly good. Table, not bad. Chalkboard. It's not great, but it's, you know, it's fine. There's the default. Hey, I think it's working. So we go over to books. Default. They're all mushed. That's fine. Oop, let's go back to books, and we'll go with the left side, right side, and all of them. Hey, I think we got it. As far as TexQuad is working, let's go to this one. Should be a tile map. So let's look at all the tiles that are available, and we go enter plus get it. We're getting little tiny pieces of it. Background of the default. Nice. And we should get for this one some very different UV coordinates. So plus enter, enter, enter. It is sliced more horizontally than vertically. Boom. Okay. All of that worked inside of TexQuad. So now we go to this bad boy. Make it a playmat. Go to this guy, and we go to books. We can go to this guy, make it. Let's go playmat. Oh no. That's not what I wanted. Playmat. Then finally, more books. Okay. So let's go to 2. Oops. And we move to just a bookcase. Go down to text 0. Okay, that's fine, that's fine. So we can get just the table. See? Oh, nice. Okay. I would say we're not actually doing that bad. initial testing looks pretty good. Two things that can happen. We can go to no texture. Actually, TexQuad, no. So one thing we can do is TexQuad can have no texture. So it's more similar to the batch TexQuad in that way. Is that something we want to do right now? Honestly, this is looking really good. I think that's a good round of testing. So let's do Flora journal. Sandbox now has key combinations to put different textures and UV maps, UVs in different plots. Honestly, all of that worked shockingly much simpler than I thought. I thought I might have to flip my UVs, but I think I've already done that. So I think we're good. In different combinations. Okay, let's go back to our to-do. Let's take a little tech debt item here. X, tech debt. TexQuadBatch. Actually, let me just see. Image warehouse. Let me think. Source texture store. Does it ever return null? Do I assert anything? Get key. Okay. The texture store is kind of backwards of the way I wanted it. Now I'm remembering. TexQuad. Not. I do have set texture by those two. Let's do this. Set it by const texture star texture. Texture equals texture. Set UV. If M texture is not equal to is equal to null, then we actually want to texture store will never let me not load one. Okay. If our texture is now null, slot equals 0. Slot equals 1. Where do we set our texture slots? Is 4. Yeah, our texture slots are all 0 by default. Yep, -1.
That's what we talked to him before.
Set texture. There we go. That way we can clear the texture if we want to. Which means in our assets shaders, texture fragment shader. It's going to be very similar to our texture batch shader. Texture slot. Oh, we're not reading out the texture slot. Why not? Why are we not? The texture slot, I guess. Text batch. Vertex buffer. There's a texture slot. Text. We aren't using it right now, but we sure can. Each coordinate texture slot. Texture slot. There, now we're using it. Okay, so what's going to happen is we're going to pass in our texture slot. We told it where it is in our buffer layout, our vertex buffer layout. We're going to telling it we're going to output it. Therefore, we get floating point value here, stuff it in there for output to our texture fragment shader, which has that as an input, so that's great. Then we convert it to an integer, and we say if the texture slot is less than 0, so it's not a valid texture slot, we're going to put in a lovely magenta. Otherwise, we get the texture, sample it, and use that for a color. I think that's it. CD tools bin / embed shaders. Now that should be all up to date. We go to our sandbox. When we're switching textures, we want another option. Textures are left and right. 5 and 6. Selected texture index equals 0. I like the option to remove our textures. Otherwise, use this one. Texture, null. Now, way up here where we use the period to print out or log quad text here. This one right there. Okay. That's close, not quite. Select texture index -1. We're using 0 as don't set one. Now period. This part still boggles my mind where the plus and minus don't work. Oh, they do work. Oh, they don't. Okay, well, whatever. TexQuadBatch. Pretty sure that I was able to set a texture. TexQuadBatch. Set texture. Set quad texture. This one. No, I don't necessarily want this texture to not be null. I want to be able to set it to null if I want to. The current texture is the same as the new texture. Current texture slot can't be -1. Remove the current texture if no other quad references it. That's fine. See if the new texture already exists. See if we can insert the new texture. So if texture slot is less than 0, and where is it? Text not equal to null pointer. Then we look for places to insert it. Texture slot is not found, and our texture is not equal to null. That means we looked for a place and we did not find it. Otherwise, we can update with the negative texture slot, and that should be fine. Back to sandbox. When we apply, underscore selected texture text index equals 0. Do this. Give it a null pointer. Otherwise, we do this. with a -1 here. Underscore selected texture quad equals 0. There we go. This should have an exact analog down here. Okay. Now we can clear quads and let's do a full clean and debug. We haven't done that in a while. Oh, okay. 30. I think we have time to do some things. Oops. Wait a second. Okay, okay. Fine. It does not have to be constant, I guess. Actually, it can. We just need to make this one constant. Okay, texture slot was not declared. Oh, come on. Are you freaking kidding me? There's only one pointer here. I can't. Yeesh. The others are an integer index, which I'm definitely not casting to a pointer. Source builds, debug, sleuth, sandbox. Hey, that's because I set it to 0. Texture null because it's set to 0. However, I didn't apply that, so why would that be that hideous color? Okay. So if we say that and enter, okay, so my texture quad is not working. I broke my texture quad. Texture fragment shader. If it's less than 0, magenta, otherwise sample it. Text for text shader. We're saying pay attention to the texture slot. We're going to output that. And we're grabbing it. Okay. Probably means my problem is in here, where we set the texture. If the texture, old texture is not equal to the new texture, then we set it, set our UV coordinates. we start with a backwards. That's not equal to 0. So we set with 0. If it's null, -1. There we go. That should fix it. Lovely inverted logic. Always fun. Angered Gecko. Hey yo, how's it going? Welcome back. Okay, that's better. Now, we can choose a different texture. So if we go to null and we hit enter, it dies. Assertion failed. We would be asserting things that we don't actually need to assert anymore. Correct. We cannot apply. We can apply UVs. Oh, nope. That's not quite true. Text index. Okay. If m_text equals null pointer. We don't have a texture. -1, 0. Otherwise, oh, not key. Image warehouse, UV key, default. Making a game in OpenGL directly? Yes. So Monday through Thursday, we're making a game with no game engine. We have 4 dependencies, and I'm not adding any more. After we finish this game, we'll make a second game built on all the tools we've got. But we will, instead of, we'll try to remove some dependencies. Right now I have a dependency on GL math that I want to get rid of in the next game. And I have a dependency on some font rendering that I would love to get rid of. But I'm not sure if I'm that good yet. But I will give it a stab on the next game. This game we're going to plow on with our 4 dependencies. Yep, everything in OpenGL. Like, the only thing in GL math that we're actually using is the matrix transforms. So it's way overweight for what we need it to do. Yep, cool. Welcome. Can't wait to chit chat. Image warehouse dot cp. Let's look at the apply UVs. Oh, okay. The index is fine. We get our UV index. If our apply UVs. Texture is not equal to null. We can do things. Otherwise, I don't think we need to do anything, actually. Let's not update our UVs. Unless we have to. That seems reasonable. TexQuadBatch. Set quad UV. So the question is, yeah, so it's very similar here. If the texture slot is invalid, or is valid, and if the texture slot specified is not empty, then we apply UVs, otherwise we don't. Yes, this is the same logic. And in fact, the error goes away. We don't actually care if we have valid textures. Where did I change the image warehouse? CPP. I don't think I changed anything. Okay, run it. Now, sandbox. I should be able to set the texture to null, and it still dies. Good heavens. GB -- args. Run it. Okay, sandbox. We're going to set. Oh yeah, I forgot to indent that. Sandbox. There we go. That doesn't matter. But we are now going to hit enter and accept that it's trying to bind a texture that doesn't exist. Therefore, TexQuad bind. Texture shader bind if m_text is not equal to null. Then we bind it. Shall quit. Sandbox. Quad texture quad, so that's this guy. We saying set the texture to null. The UV is the default and there's no other option. So enter did nothing. Curious. Let's change the texture out. Instead of do playmat, enter. Okay, that works. For some reason, it won't take null. Okay, interesting. Set this thing to, yeah, sure, playmat. Okay, null, and it blows up. Assertion failed. Okay, let's go back to TexQuad. Set texture. Set texture, this one. This is the meat and potatoes one. Our texture is not equal to our texture. Set it. Set our UV. We get our slot, actually. Let's only set UV. Our texture is not. Texture slot equals 4. We set them all. So why is null pointer slot -1? Set our texture slot. Okay. In our sandbox, we can set it to playmat, books, the green eggs, and with the original. But if we go to anything else and then null, null is setting it back to that. So it's probably a problem in sandbox. Apply the selected texture. Let's see here. The selected texture index is 0. Set our texture to null. If it's null, it's setting it to 0. So this is not picking the correct overload. Gosh, C++, why are you so stupid? Okay. This line here is the problem. In set texture, we have 3 overloads. One which takes an integer index, one which takes a character array, and one which takes a pointer to a texture. But the overload it's picking here, I'm telling it, this is a texture pointer. Don't even think of null pointer as an integer, because it shouldn't anyways. Don't even think of it that way. It's not an integer, it's a pointer. It's picking this one. So it's doing a get on null, which is in 0. That's the orange and yellow texture. So my compiler is too stupid to figure out that a pointer is not an integer. Gosh. Why do I get these sorts of things? ¿Por qué? Qué porquería. Sheesh. Me hace sufrir. I don't understand. What more can I tell my compiler to get it to pick the correct overload? Do I really have to? Oh, that's. What's this? Note. TexQuad.set texture. I'm setting myself from an index. I'm being set from an index. Because the compiler is moronic. I guarantee we're going to see 2 instances of that text. The first one will be correct. I set it by index. It should be fine. Actually, I might not even set it by index. I probably set it by name. So I should only see this once in the output. Come over here, go to sandbox, boom. Okay. Now, this is our test. We're going to set the TexQuad, this thing. We're going to set the texture to null. And the rest of it really doesn't matter. So I'm going to hit enter, and it's going to tell me how moronic it is. It's not. It did not tell me how moronic it is. So it's not calling that function. It did not call this function. I'm being set from a texture pointer. It's not quite as moronic as I thought. Let's see. Which one will be outputted? So he's being set from a texture pointer because the compiler is not quite as moronic as I thought. But I haven't hit the button yet. So where's that get set? Oh. Okay, no, that one makes sense. Because this one being set by text. Being set from a string. And this has nothing to do about whether it's moronic or not. Okay, so let's rerun this test. We are going to figure this out. Maybe. It could just be that my compiler is misbehaving. Okay. So in our sandbox, we're running the quad texture UV test. We're going to set the texture quad, which is this one. We're going to set the texture to null. And nothing else matters. I'm going to hit enter. It says we applied it, but it didn't do anything. Actually, it called neither of those. TexQuad, which is fine. Being set from a texture. Pointer to a texture. Okay, so we have to look at that. Let's take a look. Okay, it's being set from a string, which then calls for the one that sets it by a texture. It looks up the texture pointer by name, so that's fine. Now, the test texture quad to null. Hit enter. Set texture. I'm being set from a pointer to a texture. Gosh, come on, text quad. So, if the two textures are not equivalent, which they better not be because this one is null, we set our texture, we choose our slot. Sandbox. When we apply it, set texture to null. How? How can it be that null is resulting in an actual texture being rendered? We set the texture. This pointer to m_text. Modulus p going from there to the other one. Texture, which should be 0. Right. Sandbox. Enter. So it is 0. It is null. If it's null, slot is -1. Then we set all of our texture slots to -1. I bet this is the problem. It should cast those to floats, but it might not. But I'm going to need a restroom break before we continue, so I'll be back shortly. Okay, we are back. Now, our problem is this texture is not being set the way that I told it to set it. Those are now floats, so maybe making those floats will fix it. Alright, so if we hit enter, it should change this texture quad to be null and it should draw all pink. It did not. So here's the pointer to the texture that was in there, which is this orange and red one. We're setting it to null. And then, right after we set it to null, we look and hey, look, it is null. How about that? So, oh. Set texture. Maybe we need to tell it to upload an update when we draw it. Maybe that's my problem. It needs to upload the new texture coordinates in our vertex buffer. If that was the problem this whole time, hey, there it is. So we can pick a different, let's go with like the playmat. There it is. Back to null. Perfect. Okay. Now this one is going to assert certain things. So let's go ahead and select TexQuadBatch 2. So this is texture. This is our batch texture quad 0, 1, 2, 3. 3 was not set initially, so this one we're going to try and set to sure, the playmat or null, and that should fail an assertion. Because when we go to texture quad batch CPP, when we set the texture, first thing we do is we remove the current texture if nothing else references it. If our incoming texture is not null, we look for a place to stuff our new one. So, does it already exist? If we do find a match, then we can break out and set our texture slot to that. If that didn't find one, we look for an empty place to shove it. Which can go there. But that's only if texture is not null. If our texture is null, so if we found a texture slot or put something in the texture slot, if the texture slot is not valid, it's less than 0, and if we did have an actual texture, then we know that we ran out of room. Otherwise, set the texture slot for each vertex of the quad. So it's probably in set quad UV. if texture not equal to null. That's probably the issue. Either way, we need to set it as dirty. Okay, we're getting there. Anybody have any questions, comments? I'm happy to discuss anything until people ask questions. I'm just stream of consciousness, talking out loud. Run it. Sandbox. So let's go select the texture batch 2 in the playmat. Big logo. Okay. Assertion failed. $25. The call is to get key. TexQuad batch. Get key. Nope. Sandbox. Why are we doing calls to get key? This one never calls it, because it kind of doesn't care. Oh, from the texture store. Yep, so that's the problem. Texture store. Quad texture by index. Oh, okay. You know what the problem is. There we go. That will fix it. We're looking something up in the image where the texture store that does not exist. So that's now also working. So we go to text batch, texture quad batch here. We can set it to things and stuff and null. Perfect. Go to books. We can set it to the. Ooh, interesting. Books. Those are not the right UV coordinates. You should not be able to select those. I have an error and I know what it is. Select the texture index. When we type period, it prints out a lot of things. the texture. Where's the texture? Start key. UVs, we use the default one. Selected texture key, texture index 0. Then we do all this. And we do it with respect to this thing -1, texture index -1. -1. Oh. Actually, that makes sense why this is not working. This is not working. UV. Okay. We're going to pick TexQuadBatch 2. We'll set it equal to the play map, set it equal to the dough. We'll clear it. Set it to books. Dot. Left and right. So plus and minus are still off by that much. Because we have the same issue, but we're at least now printing the right things. So if we add batch 2. Playmat. Case. Table. Chalkboard. Default. Okay, all that seems to be working. Okay. So we can now arbitrarily swap out our textures, our UV coordinates, and everything else quite conveniently from values stored inside of our image warehouse. Whew. Okay, that was the adventure. I think we are ready part of this effort. Made several improvements to TexQuad and TexQuadBatch, including some realignment. TexQuad, TexQuadBatch. Now, conveniently use UVs from image warehouse. Testing in sandbox C. Okay. Whew. Not too shabby. Did I really eat both of those? Snack. I ate my snack. I wasn't even paying attention. Oh, okay. Go to the old journal. From here, we have some tasks. Let's go to our to-do list. We can now do the up button update. Right now, the buttons. So let's go back to our. Let's run it. Not this one. Yeah. So these buttons are colored quads. So I specify the vertices. I specify the color per vertex. And so when you enter a hover event, we just change the colors. We change the different things with the button. It's stuck. Oh gosh. And our texture is no longer loading. Cheat. The book's loaded fine, just not the playmat. We should fix that. We've broken our playmat. That's awkward. Huh. Okay, well, TexQuad logging way too much. All right, game scene. Playmat. That's that one right there. That is a TexQuad dot. We're passing in a text name. We start with the vertex at null. We set the texture according to name. The two textures are not the same, which they better not be, because the first one is null by default during the constructor. So these are probably all the books. 4B0940. Huh. So texture quad never was set. That would be odd because gaming scene initializes it here. I mean, we can do it here, that's fine. It would be a little odd if the constructor did not set texture. Well, maybe it's not that odd. It may be because I'm probably blowing away texture coordinates after the fact. So, not that one. Play. Okay, there's my background. So if we go to TexQuad, where we set this up. Set texture needs to happen after we net the UVs. There we go. Game scene. We can put playmat initialization back in the constructor list. File should be no different now. Set texture looks so templatable. Yes, I suppose you could. I don't really see any reason to. Yeah, maybe. I don't know. Integer, index, name, and by texture itself. There's only the three options. I don't know if it's worth templating. It's not like it's that much. It's not that generic. So, all my career, I've only really used textures one way, and I've finally heard somebody say it the way that made any sense. You ever heard of the Grug Brain developer? He was basically saying, don't overcomplicate things because you're so smart, because you are not. And one of the things in his long list of things was I only use templates for containers. Grug Brain. Yeah, that's what it's called. Grug Brain. The Grug Brain developer. Here we go. Education time. Putting it in the chat. Basically, just because you're making, and in fact, this notion goes back to the beginning of computer science back in the 50s. People were saying this, but it doesn't make you smarter to use all the fancy, new, cool, complicated features. Just keep it simple because you're not as smart as you think you are. Trying to see if he had said something about generics, especially dangerous here. Grug try limit generics to container classes for most part, where most value add. Yeah. So I think I heard the Primogen was reading through the article. But yeah, I'm a Grug Brain developer. I'm pretty dumb. So I try not to get into templates unless it's a container. I'd be interested to hear what you think about it. I know there's a time and a place to break every rule, but like, to my mind, just keeping it simple. Simple and readable. Okay. Dum-da-dum. What are we doing in to do? Oh. Okay. Yeah, right now the buttons are vertex buffer with an XY coordinate per thing. There's 5 quads. Each one has its own color. We want to update that to use the new batch texture quad, so we can set a texture that defines my button style. Because right now the buttons are not really customizable. They're very hard coded to be that gray and have those boxes. We don't have time to do that today. So maybe we do one of two things. We can either try to fix the text edit cursor issue. That one's probably not far off. When we went and made everything parent-child relationships, it's now off by half a character width or so. So it's probably not going to be too hard to find that one. But it might be more fun to do an animation. And we can do that now that we have fixed our rotation and scaling buttons. We may not do the overshoot. We may do a quad in out. So we have two things, depending on how fast we can get through them. Maybe we do these two. Yep, I love overcomplicated things. Doesn't really matter so much as you. Yeah, it's exactly. As long as you're like playing in your own sandbox and doing fun things, like great, knock yourself out. In fact, like on Fridays when we're doing compilers, I keep saying over and over again, what we're doing is not the best way to build a tokenizer or Lexer, but it's one of the kinds of complications that I really like. So that's like my personal type of complication that I like adding. Some people like adding templates. I like deriving DFA tables and building go-tos and labels that do strange and mysterious things. So okay. Now let's start with the text edit. First, sure, let's go fix that. Go to our journal, add that to our list of things to do. Clean up some tech now. So let's take a look at it. If we go into settings, this is a text, and you can see the cursor is not after the Z. And if I arrow over, it's basically centered-ish over each character. So that makes me sad. And it used to work, now it doesn't. So we just have to fix that offset problem. So in the text edit, set text size, color, set alignment. Eventually, we might want to do things like set the cursor color, etc., etc. It doesn't really matter. We're not worried about that right now. Set cursor index. Okay. If we have focus, make our cursor visible. We clear any timer state that we have and restart a timer so that the cursor will blink. Set our cursor index. Get our containing rectangle. If the text length is 0, then we look at our horizontal alignment of our text to place our cursor. If it's left aligned, we move it all the way to the left. If we're centered, we move it dead to the center. And if it's right aligned, we put it all the way over to the right. Otherwise, we move our cursor to some X offset at character, which we compute from the text object itself. So that's our next port of call. X offset at character. Yeah, I will never say anything about the way somebody uses their code, like for educational purposes. Like reinvent the wheel. Use the most complicated features of your language. Whatever tickles your fancy. Understanding any piece of the system is always better than not understanding. But I look at a lot of the things they do with templates, and it's, I think, a huge cognitive load in a lot of cases. For anything other than simple containers. All right, so we get our font data. We're going to mark a position on the x-axis. We're going to start at 0. And we're going to set our min and our max to that. Because we later have to do some alignment. If you have it like centered or left or right aligned, we have to know what our min and max x are to move them appropriately. Then we're going to walk through each character in order. If we're at the index, then we're just done. we're not done. We know where the cursor needs to be. So if you're at the 0th character, you're before everything else, we mark it. Then you have to go through the rest of the text to find the maximum and minimum positions for alignment. So it's not like we can stop. We know where the cursor needs to be on the x-axis. Then if the character is a space, we just add to our x offset the amount of the space. If it's a tab, we add 4 of those, or however many spaces per tab we defined. If it's a printable character, then we get the glyph info. We move by the amount of the left offset of the character. We get the advance. Oh, interesting. We're adding to x0. Outs in a oh. Here, maybe that will fix it. So for forcing monowidth, we just change the amount that we advance. So like, just because the character and the font define monowidth, doesn't mean that I can't use a non-monowidth font and just set the spacing equally. X plus equals the advance minus the glyph info width divided by 2. So that will move forward, minus the width divided by 2. X1 plus the width of the glyph. If that fixes it, that would be wonderful. Trying to unlearn bad student habits, though. Falling into template compilation time traps, for example. Yeah. I sat down and listened to a guy. He's like not a big compiler writer, but he's a compiler writer, right? And he explained in very great detail exactly how certain template features work. And I was like, I don't even understand the explanation. Like, I did understand the explanation, but like the syntax is so weird compared to what it's actually doing. Like, it's just almost unreadable. So that did not fix it. I think it is more correct. Text alignment adjustments, center. For left aligned, we don't need to do anything. For centered, oh, where did I set the marked? Did I remove marked X? Oh, no, this is fine. What's this line doing? We find out how much we have to advance. Minus my glyph info dot width. We divide it all by 2. Why am I dividing it by 2? I don't remember. Maybe I'm not. Maybe I'm not dividing by 2. Huh. Still the same behavior. Curious. Now I have very little confidence in this line of code here. X plus equals X advance. Oh no. This did need to be in here, didn't it? Okay. Starting to remember. If we're forcing it to monolith, we advance a certain amount, and then we place the glyph in the center of it. So we have to add a small offset to our X, but only if it's monolith. Otherwise, we just, here's our current X plus our left offset plus our advance. Okay, so this is fine, actually. And we're not forcing monolith on any of those text elements, so it would show up anyway. Okay, so that's not a problem. The other question is text edit. Am I set cursor index? Set cursor color. Set cursor timer. Set cursor index. Okay. I'll bet this is it. Boom. Oh no, 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 no. It needs with minus margin times 2. It's something like that. That's probably the line where it's causing me issues. Settings, click. Well, okay. Or just make it zeros. Remove the x-axis margin information. I don't think I need it. I think it's handled by the fact that it's in the text box. No, it's not in the text box. Settings, click. Nope, now it's just back to wrong again. So this X will not have any effect on the cursor anyway. This is immediately overwritten here. Move to X offset. X offset plus margin. That's the problem. Plus text dot rectangle. Plus m underscore text rectangle dot text. I think. Ah, that looks better. Okay, so the text had a margin inset from this colored box edge, and we were setting it on the initial cursor. But when we get our new offset from the text itself, we weren't adding that margin back in. So all we had to do is add the text margin, or text.rectangle.x, back in. Now all these text boxes should work fine. Do we want to set all these to mono width so they actually align? Or we'll choose new fonts. Okay, so we fixed that one. Yay, easy win. Journal. Done. Cursor wasn't maintaining margin. Just used text margin. Oh, it's fixed. Cursor offset issue. Cursor wasn't maintaining margin. Just added text margin to cursor position. Boom, done. Which still gives me enough time to do the animation and get that out of my to-do list finally. Oh, good. Fix text, edit, cursor position issue. Okay, to do. If I could type. This is finally getting addressed. Woohoo! Animations. Or letter color change. Rotate 360 with color fade, quad and out. Okay. Letter color animation method. Letter color animation delay. Okay. So here we have fade, fade in, out, drop, bounce. We're going to add one more. Static. Constant. Maybe we should make this an enumeration. I mean, we can do that. Is that what we do? We started off with these as integers because we didn't really know what we were doing. Yeah, let's go ahead, enum class letter state animation. Animation mode. Or method. Animation method. Letter state animation mode. Simple fade. Fade in, out. Drop, bounce. And lastly, we will do spin. Equals 3. Enum class letter state animation delay. None. Random. And wave. There's a lot of compiler errors going to pop up with that one. Letter, state, anim. Oh. Okay. Let's see here. Uh-oh. Uh-oh. This looks wrong to me. Set letter state. Okay, well, we will run into that shortly if that is the case. Letter, animation, letter state, anim method. Letter state, animation delay. Animation delay. Okay, we will get some compile errors, not least from set letter state. Games, so what's here? Letter state animation method. Letter state animation delay. State animation method. State animation delay. Letter state animation method. Letter state animation delay. Let's just see where that puts us. Oh. Okay, mode ran is not a member of. Oh, well, unfortunately, that makes sense. None. Letter state animation method. Letter state animation. Okay, here's the one I thought was probably backwards, and it looks like it is. Mode. Why? Why? Method. Thank you. All those issues. Aha, spin is not handled. Perfect. I agree, it is not, but it will be. Spin. Come back to that. Image delay is fine. There we are. Letter state animation method. Letter state animation method. Switch animation. Yep, I agree. We should handle that one. Fade it out. Drop downs. Great. To implement. All right, almost there. 4:46. Got a little time. Got a little time. We got time. Duplicate. Not simple fade. Spin. Now the easiest spin is the letters on the chalkboard. And where I want to use this spin is when we flip from notebook to notebook, so which don't exist graphically, but let's come in here, we play. Let's say that we an interesting word. We make some deductions. Let's say that we're confused and we don't know what to do next. And we want to look at this other notebook. Right now we're doing this fade back and forth. We're going bottom to top here, left to right there. Right? When we flip between notebooks. Well, I want them to rotate while they change colors instead of fade in out. So we're going to try that. That's what we're going to do. Fade in, out. Who is passing in? Spin. Okay. implement. Here we are. We need a new action sequence. Set start mode, unique weight, that's fine. Set tag, fine. We want to set basically one play animation. Let's just copy the fade in out. Simple fade. It's most like that one, except we also rotate. But, right. We can do this with 3. Set the animation, set our duration, easing method, quad in out. Set range, last color, next color. Okay, and then just add another animation at 2. Except instead of start, it's play. Using method quad in out. Instead of animation set range of colors, we want to set relative to text point to rectangle.x, text rectangle y. Oh no, what am I saying? What's it called? Angle? What am I calling it? Yeah, just angle. From 0 to constants pi times 2. Text double theta rotate 2 theta. I think that ought to do it. Let's grab this other one. We're going to have it fall through for now into fade in out, just so I don't have to fiddle around with it. We're going to see if this works. I want it to rotate, changing from red to green. It's going to be really fast. Maybe make it half second. Let's just slow it down a lot, actually. Come back to this once we're happy with the way this one looks. So that's half a second. Let's make it 1 full second, just so we can see clearly what it's doing and how it looks. Yeah, I'm afraid with old age I've become more and more of a just give me an array and an index. Give me less complicated data structures. I often don't have control of when they do things and how they do things. Not a kid. I've just become, I don't know, curmudgeonly maybe. Of course, I always tell my kids my goal when I grow up is to become a grumpy old man. So. Okay. That definitely happens. And if we switch between notebooks, they did not do anything. Ah, that's awkward. And it's just done. It's stuck. Shoot. Well, that is curious. An infinite loop somewhere. Huh. Huh. I'm going to assume it gets all the way through this, and that the problem is... Wait a second. Oh no. 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 What is going on here? Start spinning. Okay. We're going to set a breakpoint here. Game, scene, line 1000. Oh, that's convenient. I'm willing to bet. Ultra lunch would be nice. Yes. So the set of words I've selected are very memorable. So I have like little mental comics that I'll probably have to put in YouTube videos in the future when we release the game to be like, here's how you remember these words. Like for the Ultra Demon chips, or we have the a picture of like a giant demon standing over this little tiny imp. The imp's got like his bag of chips, so they're the Ultra Demon's chips. Or the Prime Lunch Toad. Obviously, you're in a cafeteria and you ask the cafeteria lady what's for dinner, and she tells you it's toads for lunch. Prime lunch toads. Prime toads for lunch. So. Thank you for not registering the spacebar. Break at game scene.cpp line 1000 run. Oh, what? Malformed line spec error. What are you talking about? Run. Oh, there we go. Run. Play. Click. Start spinning. Get a sequence. Start mode. Tag it. We get our animation. We set it up. We set our duration. Set our range. Break. Insert sequence is not null. We kind of don't care about the delay method at this point. So I bet it's somewhere inside of animation. Something I've done somewhere. Rotate to... Oh, gosh. Okay. If theta is negative, if theta is... Okay, let's do this. Double pi to equals constants pi times 2. If theta is less than 0, theta plus equals pi 2. While theta is greater than pi 2 theta minus equals pi 2. All right, we had some inverted logic there. It's gonna hang. It's gonna go to. Okay, Max, come on, give me control back. Oh, this is why you should test your code. Test your code, children. Run it. We're going to breakpoint now. We know it's going to work. We're just that good. Even placed rhino crowd lines. This does happen. Okay, then we go this one. Woo! That was kind of fun. Woo! The color didn't change. That's not what I was looking for. But it's not far off. So the quad of each of these letters is this upper left-hand corner. So when we lay out these letters, we need to set the center of that object and add that into our letter positions. Cool. That's very nearly cool. What happened to the color, though? Why is the color not changing? Color's not changing. Okay. Letters, text. On render, don't care. Nope. Nope. Next level. Nope. I think it's in do layout. Wait. Oh, that's the wave. That's fine. Letters. Okay. Each letter has a width and a height, which is letter width and letter height. So, set center double half letter height half letter width. Okay, set center half letter width half letter height. When we set the x and the y, we set them with minus half letter width minus half letter y, half letter height. Now they will rotate about the center of the letter. Just add that little offset in there. Testing sure is a lot of work, and I love cutting out work. Yes, that is true. Okay, that goes away. Those all go away. That's in. These are in. Out. Okay. Oh, okay, so they're all wrong. Woo! And they did not change colors. but this is close. Okay. Clearly did this backwards. Because the letter, okay, no, that makes sense. Last thing is that darn color. Spin. Set play animation. Set start animation. Set duration. Set easy method quad in out. Oh, I remember what the 0 is. 0 is the delay. Oh no. An action sequence. Set start animation. Or this one, set start animation. Result equals an action dot start animation. Set start animation. That's all fine. Set immediate animation start. Hmm. Rotation is fine. What's wrong with my color? Let's do this the other way around. Set. Okay, we can do this all at once. All right, ready? Set range from 0 to 1. Rotate to theta times constants pi times 2. Set color, no, set text color to where's my interpolate method? Color interpolate? Is that what I called it? Color. Nope, I sure did not. Animation. Interpolate. I do give myself a static interpolate color. Perfect. To color. Not color. Animation. Interpolate between T. Oh, T is our time, well, parameterized time, so P. Interpolate P from last color to select. We only need 2. We set the first one. Run it. Finished Red Brain. Good read. Yes. Anytime. I'm always happy to give references to things that I found interesting. Maybe I don't agree with everything 100% that I share out, but you know. I think that there's value in reading even things you don't agree with. Last color is not captured. Of course it's not. Why would it be captured? Text. Last color. Selected color. Okay. This had better work. I want that color to update properly. I don't think we need to run it in the debugger anymore. I think it's good. Okay. Well. Oh. Okay. That was wrong. Whoop. Ah, but the color is now fading correctly. Bloop. Bloop. Because we've added these strange offsets, the animation is slightly sad. Bonk. 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 Shoot. All for that rotation. The rotation is so nice. Assertion failed. Duration greater than or equal to 0. Okay, let's see. So now these other animations like bounce. We lift it up. Oh. Huh. I thought, so let's see, where's text rectangle set? I thought we were taking into account transformed rectangle. Move to shoot. The initial layout is correct. Move to plus center. So the move to does not affect the raw underlying rectangle. I bet if I do subtract center, Let me just remove this. Pretty sure I want to take into account the x-y-ness of the center offset. Click. Click. See, it looks just like we had before, sort of. Bonk. Hmm. There it is. Plus rotate. Rotate. Uh-oh. Okay. Yes, very nice. Okay, so these things need half letter width offset, and this stuff needs half letter width offset. Half letter width height. Yeah, so the center doesn't actually affect that. Okay. Good to know. View layout. So the letters minus half letter width minus half letter height. It's half letter width minus half letter height. Let's see how that works. Ooh, I gotta get going soon. I'd like to have this fixed up and ready to go though. Play. Huh. That helped, except this should be higher up. This should be closer in. This should be one more letter width. So why is that? Or half a letter width? Hmm. Reduce to letters minus. What did I put in that? Half letter height. Enter buttons. Okay, buttons. Minus half letter width. Minus half letter height. Okay. Almost there. I think. This layout all needs to be rethought a little bit anyways when we get down to the final graphics. I don't know if to fiddle with that right now. Just the X coordinate. Okay. Okay, that looks better. That's usable. Rotate. Rotate. I want them to rotate the other way. But that's exactly what we're looking for, is that effect. Therefore, game scene. Spin. Chop that out. Instead of P, it'll be 1.0 minus P. That'll spin them the other way. Will it? Yeah, it should. Or I can just negate the letter P. We'll see what it looks like. Play. A bunch of different things. And then. This is kind of poppy. Oh, that's pretty nice. Okay. Cool. So, short journal.
I need to take care of the baby and make dinner.
First part of rotating letters animation is done. Needs to apply same animation to multicolor text. Yes. Let's look at our to-do list. Gameplay, switching notebooks makes deduction letters very poppy. Fade in out animation. So basically, we fade them to alpha, change the text, fade them back in. So that's the thing we might want to do. That isn't hard. Get status, get add, get commit m. Animation for rotating letters. It's working on chalkboard. Done. Woohoo! Okay, that's going to be the end of the stream. Thanks for joining me. Tomorrow we will make the letters on the bookshelf spin, and then we will make the deduction letters transition a little bit smoother. think that's it. So thanks for joining me and have a wonderful rest of your day. See you tomorrow. Bye.